This video is about exam 2 review. In this question, I'm going to show you how to find maximum or minimum of a given quadratic function. The function f of x is negative 4x squared minus 12x. Since the leading coefficient of the function is negative, the parabola, the graph of the function, will face downward. And it has a maximum point at the vertex. Let's say h, k. Now, if the function f of x is equal to ax squared plus bx plus c with a not equal to 0, the vertex is given by the formula minus b over 2a, comma, f of minus b over 2a. For this question, a is negative 4 and b is negative 12. And so minus b over 2a is equal to minus of minus 12 divided by 2 times negative 4. This simplifies to 12 divided by negative 8, which equals negative 3 over 2. The y-coordinate of the vertex is found by plugging in this value negative 3 over 2 in the function, which gives you negative 4 times negative 3 over 2 squared minus 12 times negative 3 over 2, which equals negative 4 times 9 over 4 plus 12 times 3 over 2. This simplifies to negative 9 by cancelling out the common factors, plus 6 times 3 is 18, which simplifies to positive 9. Therefore, the maximum of the given quadratic is at negative 3 over 2, comma 9. Question number 2. You have 80 feet of fencing to enclose a rectangular region. What is the maximum area? For this question, the 80 feet of fencing of the rectangular region implies the perimeter of the rectangle. For example, let's denote the length with x and width with y. So length is equal to x feet and width equals y feet. The perimeter of this rectangle is given by the formula 2 times length plus width feet. Given the perimeter is 80 feet, we have 2 times x plus y equals 80, which implies x plus y is 40. Let's call this equation 1. The area of the rectangle is given by the formula A equals to length times width square units. Let's call this equation 2. From equation 1, we can write y equals to 40 minus x. Now we want to write area in terms of one variable. Area in terms of x equals x times, which is the length, times the width, which is 40 minus x. By distributing the multiplication, we can write area as a function of x. X times 40 is 40x, and x times negative x is negative x squared. Rewriting area as a function of x in the standard form, we have a of x equals to negative x squared plus 40x. This resembles a quadratic with the leading coefficient -1. Which means the graph will face downward with the maximum point at the vertex. With length on x-axis and area on the y-axis, we can represent the given information in terms of a graph on a rectangular coordinate system. And the maximum occurring at the vertex at some x value which we want to find. From the area function, a of x equals to negative x squared plus 40x. We can find the x coordinate of the vertex by using the formula minus b over 2a, comma, the y coordinate of the vertex by f of minus b over 2a. If the function f of x is ax squared plus bx plus c, with a not equal to 0. And so here, a is -1, b is 40. And so the x coordinate of the vertex is minus b over 2a, which means minus 40 divided by 2 times -1, which equals to 20. Now we want to find the y coordinate of the vertex. That gives you the maximum area, which is obtained by plugging in x equals to 20 in the area function. This equals to negative 400 plus 800, which simplifies to 400 square feet. Determine the end behavior of the polynomial f of x equals to 3x cubed plus 4x squared minus 5x minus 1. For this polynomial, the leading term determines the end behavior. Leading term is 3x cubed. The degree of this polynomial is 3. Leading coefficient is 3, a positive number. Here, the degree is odd number. And so the graph falls to the left, rises to the right. Since the degree is 3, this graph may have at most 2 turning points. Rises to the right false left.